Welcome everybody. I can see there's 201 people here, which I think makes it the largest meetup I've ever done. This talk is well, the name of the talk is Probing the Unprovable, Proving the Improbable, and Improving Your Program's Probity, which I think confused everybody who had to work with that title. I will try and explain what these mean over the course of the talk, which will basically be about two libraries I've been working on, plus a little bit at the end on how Scala 3 may change things. But before I start, I'd like to thank Commerce Tools for sponsoring this event. And for me, as I earn a living through giving training, and haven't been able to do that for the last few months. So I'm grateful for Commerce Tools for sponsoring this event, and also to Sandra and Zyverge for organizing it. And Commerce Tools are hiring, as Andrea said at the end. So one of the not so many companies that are hiring at the moment. So if anybody's looking for a new job, then speak to Commerce Tools. So types versus tests. Well, this is not a talk about types versus tests. I want to show you more how you can use both and how different approaches have different applications, and they can be very complementary to each other rather than a choice. And this is therefore going to be a talk about both types and tests, and playing a little bit more on the all these words about proving, probing, in German probieren, to test. This is using both the type system to prove the provable, and using tests to probe the probable or the probable. So attacking the second point first, probing, or was that the first one? No, it's probing the unprovable. I'm getting lost in my own wordplay here. Probing the unprovable. So if we can't prove something, and we would prove it using the type system if we could, by virtue of the Curry-Howard isomorphism. If we can't prove it, then we should try to probe it, that is to test it. Now, probing doesn't prove anything with absolute certainty, in the same way that using the type system to enforce constraints on your data, your model, can. But if your software passes the tests, and if those tests are comprehensive, then you can say that it probably works. And you probably shouldn't say anything more certain than that. It's not a proof, it is mere probability. And the first half of this talk will be about a library, a testing library called Probably. And unlike many of my other talks that I've given in the last couple of years about libraries, you can actually download this from Maven Central after the talk and use it. It's available, and as you will see, it's very easy to use. Often I have so much trouble publishing things that I end up giving the talk and you think that's cool, but then it's not available. This one is. So when do we test? Well, if our type system is already enforcing constraints, it's enforcing invariants, then there really is no point in a language like Scala to have tests that prove something that we already know. And for this reason, we want as much as possible to use the type system to enforce those constraints, to enforce invariants. And I kind of see my career progression as bringing more and more stuff from the dynamic world to the static, to try and encode more and more things in the type system, so that we catch errors at compile time rather than runtime. And that's great when we can do it. And gradually over many years, I've been able to do more things with Scala types that do this. But we can't do everything. There's some information we simply don't have at compile time. And this is where tests come in. Now, I want to emphasize this point. Probably is a test library. It's not a test framework, and it goes to some effort not to be a test framework. It doesn't try to bring in lots of dependencies or enforce any certain style of coding or even any kind of layout. It's as agnostic as I can possibly make it. So designed to be orthogonal to other libraries. And one of the things that, one of the approaches it takes is that every test is an expression or a statement. These are two of the most absolutely fundamental things in programming. You have multiple expressions per line. You have one statement, often one statement per line. And a test is just another one of those. A check, there's no fancy syntax. It is simply a Boolean predicate applied to some value. And a suite of tests is just another test. And I'll show you how that works a little bit later. But what this means is that tests are, or suites are, composable. You can have a suite of suites and they behave just as tests do. So straight in with some code. This is a very simple test. I'll let you spend about 3 seconds reading that. And then I've highlighted the word test here. This is an object which is the test runner. And we apply to that a string, which is the name of the test we want to define. And then we have a body which produces some value. Now we're testing that two numbers, the sum of two numbers is even. I should say two identical numbers. We're doing this just for one particular choice of a number, literally 3. And we then check with a lambda that body, the underscore in this expression is even. So that I hope is very readable. Now this is just an expression because this will return int. It will return the number 6, as it turns out. We can know that at runtime, but at compile time we can know that it returns an integer, which means that you can embed this test anywhere you can embed an expression. Now when we've run several tests, we can call test.report. Remember, test is the test runner object, and report will return an object that includes all of the results from all of the tests that have been run. Now, the most fundamental idea in Probity is it's hardly even an idea at all. Tests are evaluated when the program evaluates them. It almost seems too simple to be worth saying, but there's a history of test frameworks which don't do it this way. They use things like reflection to find tests and other approaches that maybe use some magic so that we can define tests maybe slightly more easily. Probably doesn't do that. It just has tests as normal code, and if your program, when your program runs, doesn't run a test, then the test doesn't get run. That's your fault for not having the control flow pass through that test. They maybe run more than once, in which case you get an aggregation of the results of the test being run more than once. In general, they can be run anytime, even non-deterministically. They can be run in response to a stimulus. So you could have a test that is in the handler for a web server, send a request, runs the test, processes the request, but also records the result of the test in the process. You can literally put them anywhere. Tests are just expressions or statements. So I'm going to list a few examples just to emphasize this point ad nauseum. You can put a test in a main method. That's probably one of the most obvious places. You could have it on the right-hand side of a pattern match in a case clause. You could define a test in the REPL. You could define it in a method in in the REPL and run that method multiple times. In a web server, you could put a test in a constructor. You could put one test inside another test, and maybe there are reasons why you'd want to do that. It's not that crazy. You could have one in a lazy val. You could work out if that lazy val gets when it gets evaluated. You can put one inside a future. So if you want to run tests in parallel, you can put them inside futures. You can put them inside threads and dispatch them to some sort of execution context. You can have them in actors, in the extractor for a pattern if you want to get do something really interesting. You could even have them run at compile time in a macro and have that macro also print out the result of the test when the macro is running. You can put them anywhere you can put a print line. So I mentioned at the beginning that tests are expressions or statements, and this is a choice. If it's an expression, it uses the method check. So here's an example of that. The expression test is checking that 1 + 1 is equal to 2, and the method name you see called on the test definition is called check. And this, as well as running the body, as well as checking that the response to the body is the right value, it returns that value. So an expression returns a value, whereas a statement is going to return unit. And this uses a different method to indicate that, called assert, in the same way that the standard library assert method exists and either returns a unit or throws an exception. And that looks almost identical, except for the use of the word assert instead. Now I've said here that it might be skipped by the test runner. So given that it returns unit, it doesn't really matter to the rest of the program whether that test runs or not. And if you have a test suite or maybe a whole tree of test suites and you want to just run one of those tests, you want to skip over most of them, focus on one in particular. And if you skipped an expression, that would change it would change the behavior of your program. But if you skip a statement, it won't make any difference because it's a unit either way. By the way, if anyone has any questions as I'm going, and if any of the moderators feel like it's worth raising them with me, I'm happy to break and answer questions. So please ask away. Otherwise, I'm just going to keep going. So the test runner object that I mentioned, this is the thing that is conventionally called test. It gives us the methods to create and run tests. And it will record those, the results of running the test as side effects in its internal state. That state is not accessible, but it is recorded. It's not accessible until you produce the report at the end. So you run a series of tests, you then run test.report, as I showed you, and that gives you back an object which represents the results. You maybe spot the word side effects here and get a little bit concerned that this is an unprincipled approach to running tests. I mentioned before that you can write a test, you can write a probability test anywhere you can write a print line. And this, I claim, is a desirable thing. Now, there are side effects, but those side effects are well understood and they affect the state that is internal to the test runner. And that state is effectively locked inside. It can't have any effect on the rest of the program unless you make your program dependent on the report that is produced. So I'm going to claim that in this instance, side effects are good. It means we don't have to pass around some sort of IO-like object. There's also a command line interface for invoking these very easily. It's an abstract class which has a main method. You have to implement a run method. That run method as a parameter gives you the test runner. So this parameter here, which is conventionally called test, but you can call it something else if you wanted to. You define that run method, you put all of the tests inside that, and then when you call the main method of the the main class, it will execute those tests, and it will print a nice report at the end to standard output. I'll give you an example of that in a moment. It'll also read command line parameters. For example, if it should only handle one test or a subset of the tests, statement-based tests, then you can specify those on the command line. So here's an example of a suite, which is an application. You can run it. It defines a main method, which you can't see. You just have to implement the run method. And this does a really trivial test of checking that if you join hello and world together with a single space in between, it's 11 characters long. So very straightforward, I hope. And here is some output from Probably. This is a set of tests, all of which pass. This is just what gets output when you run it. Run a suite from the command line. You'll see also that we have a time figure here. So it actually times how long these take. Now, this isn't really micro benchmarking, but it's an indication as to how long was spent in the process of executing the body of the method. And I haven't got a screenshot of this, but if one of these tests is run multiple times, you will actually get 3 columns. One will be the minimum time, one will be the average, and one will be the maximum. And it'll also tell you how many times the test was run in total. So imagine if you did have a test defined inside a web server and you fired a few requests at it, you might want to see what the average time spent on each one was, also the minimum and maximum. Here's another test that I'm simply running 10,000 times. So it's as simple as this to run it multiple times. I've included this additional parameter here, iteration equals I. Now, this test quite obviously will pass successfully every single time. But if it didn't, it would be useful to know what the value of I was at the point it failed. And that will be printed in the debug column with the word iteration. This is using Scala's dynamic trait. So you can put any word you like in there to describe the parameter. This is a reference, this I here is a reference to the actual iteration. But if it fails, it'll say that it fails at iteration equals some number. We can even do property tests like Scala tests. And whilst I didn't really want to reinvent Scala test, sorry, I don't mean Scala test, I mean Scala check. While I didn't want to reinvent Scala check, it was actually quite trivial to define the generators that are required to specify a stream of random types. I use Magnolia to automatically generate persons at random with random names, random ages. And I'm going to stream 100 of those, and for each one, I will run this property test. And I'll record the input, so it will print out the input in the debug column if one of those fails. And the tests I've got here check that the name is at least 6 characters long, checks that the age is non-negative, in fact, non-zero, and it checks that it's within reasonable bounds. I think there's one person who ever lived older than 120, so she would have broken this. But this will probably fail when one of the random persons that's generated is passed in here. And hopefully you can see from this that the mechanics which deal with the testing kind of works completely independently of the mechanics that deal with generating the properties. We generate a stream of persons, and then independently of that, for each element of the stream, we run the test. And the two, I mean, they work well together, but there's no dependency between them. Here's a definition of a suite. We can define that inline, where we define the test runner, and this is a this is what was previously called test. In this particular suite, I've given it a different name from test because we're using test as the outer suite. You could even define the suite in a different file. That wouldn't be unusual at all. So this is going to parse an empty array and check that it got a result. And then there's another example here. These are two tests in the suite. One is an expression test. One is a statement test. So the expression one returns a result. We actually get the body of this out, and we save it in the identifier XS, and then we use that in the second test, the statement one. So you can see that it's impossible to skip the check, the expression test. So that will always run, even if you don't tell it to run. But the runtime could quite easily ignore this one, and it would just not record that result. If the tests are defined in subtypes of or subclasses of suite, then we can just pass them in with another name here. So test.suite. These are themselves tests. And the output from that will look something like this. This is the set of results from some of the tests in Fury. And we've got an error there. Marker file as executable is not working. And that's something that I should probably look at. That has an exclamation mark next to it to indicate that it failed. There's a key at the bottom, I think you probably saw on the previous screenshot. The test suite, path tests, is marked with an orange hash because it didn't entirely succeed and it didn't entirely fail, so it's neither a success nor a failure. And that caused the IO tests, of which path test is one subsuite, to also be an incomplete success. And if you look at it, you'll see that the suite here, IO tests, is 0.17 seconds. The path test was less than that. And then each of the steps in here was quite a bit less as well. And they automatically form this nice hierarchy, so you can see how they're structured.
John, do you want to stop for a second to answer questions?
Yeah.
I was supposed to remind you, so here I am.
Well, it's good to have someone interrupt me so that I know that I'm still connected and not just talking to a dead computer.
Yeah, if you can just open the QA part, we can start with Leo Benkel. That since you started and we have like 5 of them there.
So I've just found the Q&A.
Okay, perfect.
So Leo, what is the difference between with probably and a simple require or ensure or assert? So I actually can't remember what require and ensure do. I think these were added to these were added as extension methods to the standard library quite a while ago now, nearly 10 years ago, I think. Assert will throw an exception if it fails, which doesn't really help you. It makes you aware that your assertion is not true, but it doesn't help you. Doesn't record it. It stops your program running. I hope that's a sufficient answer. I've never found them useful, actually, assert or require. Now I need to find the next question.
Dominic, can you see it? Then we have Ivano and Justin.
Yes. No. There's another one from Nabil. That's. In fact, I'm looking for Leo's question.
Oh, it's already. I moved it to the answered ones.
Okay. This is why I was confused.
Yeah.
So, and Nabil's is therefore from the previous talk, right?
Exactly. So the next one is Dominic.
So I would put these test expressions in my normal business logic instead of putting them inside dedicated test classes. That is a choice for you. The idea is that if you had a running production system and you wanted to do some things that you would normally do with, like you just wanted to check whether what something is at runtime, you could wrap it in an expression test and it wouldn't change the behavior, but as a side effect, it would record the result. So the idea is that you can modify an existing system, and you're using the same libraries you would use to define a set of more traditional unit tests that would be defined in a more linear format in a separate class or object. So the answer is yes, you could. Now, there might be questions about whether you want to start littering your code with these tests, because it probably does distract from the business logic that's there. But generally speaking, you that particular instance is for cases where you want to do some quick debugging. So Ivano asked, does the CLI work only for ZSH like Fury? And my answer to this is that there is no tab completion on Probably yet, but there will be. And when there is, it will work on ZSH Bash and also Fish. And the reason I can say that is because I have another library which I haven't talked about yet called Exoskeleton for dealing with shell interaction. Hopefully you get the pun. And so far that is working with presenting tab completions automatically. You define them once in code and they work straight away with both Bash, Z shell or ZSH and Fish. And I wrote that with Fury in mind because I know that there's nobody really using Fury yet, but when I do publish the release in a little while, it will support both all of Fish, ZSH and Bash. And Justin, does the property testing support shrinking? No, it doesn't. It'd be nice if it could. And I think so the I'm not sure how to present the property testing. So Scala check is a hugely successful and comprehensive property testing library. And for Probably, I implemented something really quite quick because I could in about 20 lines. And it's a novelty demonstration that it's possible. I don't have an idea for how the shrinking would work, but it would be fantastic if it could be contributed, or if someone could maybe just chat to me about the algorithm and we could look at how that would work. And without saying anything at all against Scala check, I don't think having an alternative way of doing property testing would be a bad thing. So,
okay, I guess we're done with the questions.
Yeah, there's a little bit more on Probably, but
okay.
Then I will move on. No, I just wanted to here's an example where you can run the tests from Fury. This will invoke Probably. And you can specify, as you could see here, each of these tests has a hash. And you'll be able to type the hash there. Instead of specifying the name as a full string, you just specify the hash. And this is where the tab completion will be provided automatically later. And you'll be able, if you get the first couple of characters right, you've probably got the right test. And you can specify running only one like that. So I'm still calling it experimental, but the library is simple enough that I don't anticipate huge changes in the API. And I feel a little guilty about this because I know that huge amounts of work, more than one order of magnitude additional work went into libraries like JUnit and Scala test and others to provide hugely comprehensive testing facilities. And I haven't really attempted to do anything that is the same, but instead I've tried to produce something that reuses everything else that's out there and just provides the minimal you need to get testing. And anything else, any other special features should in theory be brought in from another library that focuses on those. The benefit, I mean, from my point of view, is I spend less time writing code. The benefit from any user is that there's much, much less to understand about Probably. You can read the code in probably half an hour, and it should be quite easy to understand. It's available on my GitHub page. It's Apache 2 licensed, and it's also available on Maven Central. So I managed to get it published, at least for Scala 2.12. I will try and do 2.13, and I think I'll probably not do a 2.11 version, but 2.13 will get a version soon. So com.propensive, probably 2.12, 0.40 is the current release. And that was the end of the first half, and it brings me on to the next part of the title, which is proving the improbable. So having told you all about testing, I'm now going to say that we want to reduce the amount of testing we do. And we want to use types as much as possible to encode our constraints. And the kind of issues I want to reduce, are runtime exceptions. So exceptional cases, I don't want to discover a runtime failure by seeing a stack trace. I want to make sure that every possible exception that may be thrown by a method is somehow handled. So I'm going to present a library which is called Quarantine, and you probably think, well, this is a library name I came up with while I was in quarantine. No, actually, I came up with the name in about October last year. You can check the creation date of the repository on GitHub. I don't know if that's ominous or prescient or what, but now seems like a good time to be presenting Quarantine. And exceptions, these are our runtime failures. They are improbable, by which I mean they're not your happy path. Your happy path generally should be the most common route through your code, but they're certainly not impossible. And we have available to us at compile time actually more information than I think we usually take advantage of. And as a consequence of that, it becomes a little bit too easy not to handle exceptions in Scala. It's a bit too easy to forget to handle them or to allow them to be handled at a higher level when we would actually rather handle them sooner. So let's talk briefly about partiality and totality. Any expression in Scala may be partial or total. If it's total, whatever input you give it, it will give you a result back. There is no input you can pass to you can put into an expression, a total expression, that will cause an exception to be thrown. A partial expression will have some, or may have some inputs which don't produce results. And the only way out of not producing a result, we can't have the JVM just suddenly stop dead. I mean, we could, but it's not useful. The way out is to throw an exception and to start bubbling up the stack to a point where we know how to handle that. Now, if we compose only total expressions, we end up with a total program, or at least larger total expressions, which is entirely a good thing. It means that we know whatever input we give it, we get some input back. And if the types we're using to represent the inputs And the types which we're using to represent the outputs are well defined. They only represent states that you actually want to express in your program. This is fantastic. It means that you give it inputs which are proven to be valid by the fact they're encoded through a certain set of types, and you get values back which you know must be self-consistent because they're also encoded in some types you've defined. And nothing can go wrong in between. And this is, I think, what I'm saying in this slide here. We should design types to make invalid states unrepresentable. That's one of the most useful pieces of advice for working with a type-safe language. So exceptions are the JVM's encoding of partiality. I've jumped ahead of the slides with my my rhetoric here. Now this third point here, we're not forced to think about how they're handled. This is quite convenient when you're writing script-like code. You don't have to handle the exceptions, every exception that might be thrown by a particular line. If you're only going to run the program once, or if it's run by a user and the user sees the error and can then go and replace it, go and fix it with some different, replace it with some different inputs. You're allowed to write the program thinking only about the happy path, and this is convenient for those sorts of script-like programs, but it doesn't work so well for production applications where you really want to make sure that at least as much of your data flow is total as possible. So let's think about how we represent failures without using exceptions. Here is maybe the most trivial way of doing that. We could have an option of the result type. If we had a success, we would return some t. If you had a failure, we would return none. That has a big disadvantage, which is that if there is a failure, we get none, but we don't know what the failure was. We don't know why the thing broke. And to help here, we have the try type. Looks very similar, except it's called try. But in the case of a failure, you have access to the object which represents the exception, and you can access that and find things out about it. But you don't know statically what kind of exception it is, or even what kind of throwable it is. It might be an IO exception, it might be a runtime exception, it might be an arithmetic exception. Statically, you have no idea. So even if you're doing something really, really well understood, you know the exception types that may be thrown. If you're returning a try, all you know is that some kind of exception was thrown statically. At runtime, you have access to it, so you can inspect it. So the next approach we could potentially take is to use either. And since either became right biased, which means that the success type t can be chained together monadically, and the left type can have some subtype of exception, can use some subtype of exception to represent only the set of possible exception types that you want to return from that either. This gives you more type information at compile time on the exception type. So if, for example, we had some sort of file system operation, we might use either of IO exception and int to represent that. Now that's great, except that every time you want to write the return type, you have to write either IO exception, int. And the happy path, or the happy return type, is this one here, int. Whereas for me, just visually looking at this, the type is dominated by the exceptional case. So what I propose in Quarantine is a path-dependent type. It's called result. Here, as the parameter, you see the type of the result. But there is a path here, a path which I'm calling domain. And what I want to do is encode within that path. I'll show you how later. I want to encode in that path details like the IO exception, because I have a benefit that as a path-dependent type, I can import from that domain, and I get the result, and I can use that within some scope where that domain is imported. I can use it as I would use option or try without needing to specify the exception type, knowing that domain encodes it. So let's start with not the actual implementation of result, because you can see here it's got 2 parameters, but let's start with something that is basically equivalent to either. So here is the results. We have an exception type on the left, we have the success type on the right, and I've just defined a couple of methods. These don't exist in the actual quarantine version, but success will give you an option of T if it was successful. Failure will give you an option of E if it wasn't. Now I'm going to introduce this type called domain, which will encode the exception in its own type parameter. Then as another step, I'm going to add a reference to that domain as a constructor parameter to class result. This is just the first step of a series of steps I'm going to take you through to show how you can go from the either-like representation to the one I've got in quarantine. Now you can see here that the domain is parameterized on a type E here. This E is unchanged from the previous version. Well, it's a subtype of exception, but that's I don't need to write that. And whichever instance of domain gets passed in here, we will statically be able to bind that E type to the identifier E here, and that will be the type that is returned with the failure. As our next step, I'm going to make that a type member. So you probably know that type parameters and type members behave in a very similar way. They have some differences, some fundamental differences, but it means we can refer to domain here without explicitly specifying the type E. That means we don't need to specify the type E in the parameter of result either. But it means that in our option here, we need to access that type member through the path called ref, which is the domain. So this is all equivalent. Each slide is equivalent to the previous one. Now, what I've done here is I've nested result inside domain. Domain here is, I've used a self type or a self name to call the current domain. And I've got a value here which I've maybe intriguingly called $outer, which has a singleton type domain.type. So it has the same type as, so it would be this.type if you're inside domain, but this.type inside here could be misunderstood to be referring to the result. So I want to make it very clear that this is the singleton type, the this type of the domain. And this was previously called ref. This is the same as it was before. Now the magic is that outer reference always exists already. We have that anyway for any inner class. So what you maybe don't know is that when you nest one class inside another, you get a sort of secret parameter added to the class, which is called outer and points to the surrounding class. In this case, it's domain. So we don't need to explicitly include that. We simply omit it, and this is the same as the previous version. We can then move that type parameter back out, so the type member back out to a type parameter. And then this looks a lot simpler, but we've gone step by step through to this much more simpler representation. And this resembles the structure that we have with quarantine. Now, am I still connected, Sandra?
Yes, you are.
Yeah, sorry,
all good.
It was silent for a little while, and I noticed 2 or 3 messages arriving on my phone, which I wondered if it was people telling me.
All good.
Good.
Let's go.
So this is how we would use it. We would construct a new domain. That's as simple as saying new domain, specifying what that exception type is, and then we could define a result which is a path-dependent type on that domain. So we're using the result type that is dependent on the path, which is this value here. On the right-hand side, you can see I've used answer. Answer is the equivalent of success. So this is the happy path. It becomes a little bit nicer if we define the domain, then import everything from it. We can just write result there. Answer is the happy path. And then there are 2 more here called error and, intriguingly, surprise. Now, given that we are trying to encode within the domain type the types of exception we want to handle, we don't want a different exception to completely blow up our stack. We want to handle those as well, but if we're not expecting them, they're kind of a surprise. So we've got 3 different possibilities here. There's success, there is expected errors, and then there are surprises, which are the throwables, which we weren't expecting to happen. They will be wrapped in a surprise, and there are methods for handling those specially. And by the way, we won't ever catch catch fatal exceptions. We'll use the non-fatal extractor to make sure that if we have out of memory or something like that, we do keep throwing that and we don't try and handle it. So let's look at results. 3 subtypes: answer, error, and surprise. And if there are fatal throwables, they are thrown. So I already said all of that. Let's look at an example using JSON. So imagine we can parse a string into some sort of dynamic JSON object. That could fail to parse. Now, extracting from that dynamic object a particular known type could produce other issues. It might be missing, it might be there but the wrong type, or it might be invalid if we've got some sort of validation going on as well. This is all hypothetical, but hopefully you'll get the idea. If we parse straight from a string to a typed value, parse, error, missing value, wrong type, or invalid are all possible exceptions that may be thrown. So now we have a lot of code, and I'm going to show you the first chunk is setup, and I'm going to use sealed traits and case classes, and if you can trace through which case classes inherit from which sealed traits, you'll see that extract error is a subtype of JSON error, which is a subtype of exception. So there's a hierarchy within our sealed traits. And what that means is that invalid, missing, and wrong type are all extract errors, which means they're also all JSON errors, but parse error is just the JSON error and not an extract error. We can then define some domains: parse domain, extract domain, and JSON domain, which are going to encode in the domain's type the types of exception that we want it to capture. So parsing is parse errors, extraction is extraction errors, and JSON in general is a JSON error. And we'll define some methods which may appear somewhere inside our JSON API. parsing takes a string and returns a parse domain result. The as method, this is what converts from a dynamic type to an actual typed value. This is going to return an extraction result, and likewise, if we define parse as going straight from a string to a typed value, this will contain any of those four possibilities. And this is what the code might look like. We have some JSON, we try and get a string out of it, and we know as programmers that there are three possibilities that might be thrown by that: invalid, missing, or wrong type, and we handle them in some way. We're getting a string, so we return some sort of string. If it's missing, we give it a default value. Otherwise, we're going to print the word or return the word error. This works. Nothing really to see here. But if we were to remove wrong type, if we remove that type, and if we have exhaustivity checking, well, we do have exhaustivity checking. If we have fatal warnings, then this becomes a compile error. And this is what we want because we've forgotten to handle one of the cases. It's a perfectly valid possibility that the JSON represents an integer. We try and get it as a string, and it's the wrong type. And without this line here, this would normally be a match error, which would be an exception thrown, and it would bubble up the stack. Instead, we've converted it to a compile error by very carefully knowing exactly the types of the errors that might be thrown by the extraction. Recover is just one of quite a few different methods that exist between the different types. And I've drawn a subset of them here in this diagram. There are familiar things like flat map and map. So I didn't explicitly say, but you probably guessed that result types are monadic, so you can flat map over them. Note that I've got D1, D1, D1 here, and now over this side I've got D2. So if you want to go from a D1 domain result to a D2 domain result, imagine that D1 is the JSON domain, some sort of JSON domain, and D2 is your own application. And you want to deal with your own application exceptions within your own program. So there's a method called adapt, which will automatically convert from a JSON error to an error in your domain. And you may have multiple domains. You may just have one for the entire application. That's a choice for you. If we get a surprise, so we don't like surprises, so we want to mitigate them, we can convert surprises into errors just by calling mitigate on mitigate on the results, and that will leave errors unchanged. It will leave success values unchanged, but any surprise will be converted into an error. If we have an error in our D1 domain and we want to represent that in our D2 domain, the application domain, we can diagnose that. And there are other methods as well, and at some point I will get around to documenting all of them and the way to use them. But generally speaking, between any combination of domain and subtype of result, and also type of result, there are methods to convert between them which have appropriate names. So this is quarantine, and I can ask the question: how do you go about quarantining your code? So if you're a library developer, what you want to do, and library developers should bias all the hard work into the library so that the end users have the benefit that they do less work. So it's a bit more work to specify the return types, but in a library you're more willing to do that because of the reuse you get from it. Carefully design the domain so that every combination of exception you might have returned by a particular method is encoded in a domain and therefore in the result type. You return that result type for any method that might have a failure, so it becomes total. And then for application developers, the users of this, what you probably want to do is define your own application domain with the exceptions that you want to be handling in your code, or in the particular layer of your code that you're working with. You can define implicit adaptations from the other domain into yours. So you can maybe say that anytime a JSON error occurs, whether it's come over HTTP or read from a file, maybe you just want to say that is a third-party exception. You don't care exactly what the detail was. Maybe you record it in the message in that exception, but you want to aggregate all those errors into something else. Or maybe you actually want to inspect. If it's an access exception, treat that differently, map it to a different exception than you would if it were a parse exception. You can define implicit adaptations for the common cases, but you can also define inline how to deal with mapping between domains for individual cases. So quarantine is also experimental. I would say probably a little bit more experimental than probably. Just notice I use the word probably more frequently than I should. Quarantine is experimental. The source is online, and also it is available now on Maven Central. I published it about an hour ago, so version 0.40 should be available there. Now I've got a few slides at the end on Scala 3 and how that could improve the usability of quarantine. They will take about 10 minutes, I think. Shall I do those and then take questions on quarantine in general? I haven't checked how many have been arriving.
Just a sec. There are a few. Yeah, like around 5. So do you want to take them now or later?
Let's take a look at them now, and then anybody who doesn't care about Scala 3 can give up now if they.
Okay, so the last one was from João Costa. If you can take at the QA at 7:13, so quite long ago.
7:13?
Yeah.
You mean 8:13? We're in different time zones.
Oh yeah, we are 7 my time. Yeah.
Does it support Scala.js, Scala native? Yes. There's nothing in. So this is actually true of Probably as well. There's nothing. There's nothing about Scala.js that would stop you using quarantine. And the reason I say that is actually not because I've tested it. It's because I know that all of the complexity is done in all the complexity with quarantine is done with type checking in the compiler, and Scala.js is a phase that happens after that. So it will just compile to Scala.js. As I should probably drop a little advert here, which is that I've recently merged a pull request to Fury, which allows Fury to build Scala.js very easily. You don't even have to install anything. You just say save this build as a JavaScript file, and it will. That's coming soon, still coming soon, but getting much closer. Which is the next one? 8:35.
Yes, Mike Limański.
What is the goal to inherit exception instead of using custom ADT for error representation? You don't have to. It's a good point. I generally, if something is an exception, even if something is representing an exceptional case, I will generally make it a subtype of exception, even if I never intend to throw it. Now, there is one benefit from that, which is that these things may get thrown as exceptions if you want to use them in that way. So there is a method which I think is, I can't remember if it's called get or unsafe get, which will throw exceptions if there are any. it'll convert the errors to exceptions. It'll convert answers to the actual value. And if they're not subtypes of exception, you can't do that. And I think it's useful for people who do want to code in that way to be able to do that. So it's literally so they are throwable. Now this also has there's another side to that, which is that people may have set up their existing domains to have types that are representations of errors, but are not subtypes of exception, and you'd need to have them extend at least throwable to get any of this to work. I'll have to think about whether it's worth relaxing that constraint. There are pros and cons, but at the moment it assumes they are subtypes of exception. Okay. I think Joe's question is kind of similar.
Exactly.
Yeah. So the same question.
I'm gonna move it. All right. Yeah. Jakub.
So Jakub asks, does handling all exceptions change the type to one without errors? Yes, there is a method for doing this. And the methods, because there are so many different, there's three subtypes we deal with. Generally, you're sort of going from surprises to errors and errors to answers, and the methods are called mitigate and recover, and you would run them one by one. If you've mitigated and you've recovered, then you get a successful failure. There's another method that goes from maps from one error type to another, which is a variant of adapt. I think it's a little bit like the collections library. I mean, not quite as bad as the collections library, but there is a bit of a dictionary of different methods with different names for representing all of these transitions. And I'm going to have to expand the diagram that you saw a couple of slides ago, or include some sort of table that indicates which methods go between which different things. Because what you really want to do is identify them by signature. If you know the signature, you usually do, then you can do that. I've just spotted the question about Zio. Dominic asks, he gets the benefits, but why should I use it instead of Zio and let the fiber die on unexpected exceptions? Well, I mean, I don't know the answer to my own question, which would be, what happens if the fiber dies? How acceptable is that? Now it's possible to these types compose, so you can use a Zio IO type with a result inside it if you wanted to. You can convert potentially from a result to a Zio IO. Falco asks, does Quarantine have any documentation? The answer is not quite, but I think the GitHub page at the moment is an even worse representation of the current state than reality. I think I have some unpushed changes which have partial documentation. I wanted to find time to finish it off with more documentation on what those methods are, but I didn't find time. And then Yannick says, how do you feel about surrounding result with something like future or IO, which adds one more layer of exceptions? And then we're sort of getting into thinking about monad transformers potentially. I will say that it is possible to do that. You can nest them, but you may find yourself mapping within maps, or flat mapping within flat maps, or doing a lot of traversals or sequences. I don't know if there's a good way of composing these various higher kinded types And I say that with the anticipation of Scala 3 offering us some new ideas on that with its new type system. There may be possibilities that come later in Scala 3. I don't know what they are right now. I'm hoping that I'll be able to explore them over it'll be the coming years, I think. And we will maybe discover some better way of kind of merging together IOs and results and lists and options and so on. But this is, for me, this is purely speculative at the moment.
So this is it in regards to questions. I think you can move on to the Scala 3 part.
So thank you, everyone who's been hanging on for this. Maybe you only came for the Scala 3. So you might have been thinking while I've been talking about this, I defined all those sealed traits, which give us the ability to do exhaustivity checking on the various partial functions that we define with quarantine. Scala 3 gives us union types for the first time in Scala. And we can use these as an alternative to sealed traits. The main difference is that we don't need to define the unions in advance. So with sealed traits, at the point you define the subtypes of the sealed trait, you need to define the sealed traits themselves by definition, literally. With ad hoc unions, we can take any combination of case classes or exception case classes and put them together in a representation which is a union type that says it's either this type or it's this type or it's this type and so on. And one of the key features of that is that unions of types are subtypes of larger unions. I'll illustrate this in the next few slides, but what that means is that if you have some union of types and you have a bigger union which contains all of the alternatives in the first union, there is a subtyping relationship between them. So let's take this step by step. Imagine we have a JSON exception and an HTTP exception. First of all, I want to rename them to JSON error and HTTP error, mainly for making them more concise. A JSON error by itself is a subtype, and this is known at compile time, of JSON error or HTTP error, likewise with HTTP error. Consequently, a union of two types is a subtype of a union of more than that, which also contains those two, and they can be reordered as well. So the pipe operator commutes, and as long as the set of things on the left is a subset of the set of things on the right, and there's a union between them, there is a subtyping relationship. So this is one of the rules that Dotty encodes. So more generally, A or B is a subtype of A or B or C. I'm going to just write it like that because we can take another step, which is to wrap that in a domain. The idea is this will be the same kind of domain as we had before. And as long as domain is covariant, so that's what that plus is there, the subtyping relationship will be maintained, whether it's wrapped or whether it's not wrapped. So for people who haven't fully explored variants, what this plus means essentially is whatever the relationship you have between two types, wrapping them in some sort of covariant wrapper will not change that at all. We can also make that a projection type. So we can project on that domain to access within the domain a result type parameterized on T. So the projection type is indicated by this hash here. In Scala 2, projection types are a special kind of existential. In Scala 3, they kind of exist in their own right. They're not really defined in terms of existentials, which are complex and difficult to work with. Projection types are kind of a subset of existentials, but they are much better understood with Dotty. Now I could define a couple of erased types here. Erased is a feature which is, I think it's currently on hold for Scala 3, but it was implemented and you can access it by a flag, and I think that's not going to go away. So if people use it, I think it'll be difficult to remove it from the language, but it hasn't passed the SIP committee yet. So we can define these erased values. JSON is a domain of parse error or access error, and HTTP domain is between those three. What erased means is that these values don't actually ever exist. There is no stack value or no heap value corresponding to an instance of domain. It doesn't exist, but we can treat them like a value at compile time as long as we don't access any of the members of them or access them in a value position. But we can access them as a singleton type. So JSON.type is the singleton type of the JSON value. The singleton type allows us to make reference, sort of quietly make reference to this domain here. And we can write that JSON.type hash result. So this is a projection on the singleton. This is the same thing. We still have that same relationship between them. And a projection on a singleton type, this is true in Scala as well, Scala 2 as well. That is exactly the same as a path-dependent type. So if you hadn't seen this fact before, JSON.type hash some type member is identical to JSON.that member. The reason is that a projection is kind of attempting to project over a variety of possible values, some of which may have different, may encode slightly different constraints. But if your type is a singleton type, it only ever has one value, and therefore we can know exactly what that value is, and we can refer to result literally as the member of the value JSON. Likewise, HTTP here. Bearing in mind these are erased, so the value doesn't even need to exist. So I've got some code here, which I wrote earlier. This is Scala 3, so I've used the indentation style just because I can. And it's, I've come to like it. I know it's been quite controversial, but it seems cleaner to me. So you're gonna see it on this slide. Let's define an object called JSON, and inside there will be a parse method. Now I've written out the type in full here. This is a domain on a parse error, accessing projecting to get the result with the JSON there. No implementation, of course. The JSON class representing some sort of dynamic object representing JSON that has a get method. And the return type here will be, as before, it will be result of JSON, where the JSON value is from an import. So I'm using the same trick I had before, except in Scala 3, the domain object doesn't even need to exist as a heap value. Now, the thing we can do in Scala 3 that we can't do in Scala 2 is we combine these in a single for comprehension without any additional transformation of these result types. Each one of these returns a result type. And in fact, get count will also return a result of some variety. And the nice thing is that it will be inferred to be a type parameterized on a union, which will enforce exactly the constraint we need, which is that an exhaustive partial function, so in fact a total function, will be checked at compile time. And we can know that if we handle all of those cases, then we have totality. And there is no risk that any exception would be thrown, apart from surprises, of course. No risk any exception would be thrown from that. So this is from the previous slide at the top here, but now I have the type, the inferred type included in here. Net error, of course, comes from HTTP, parse error and access error from the next two lines, and they get combined in this way. This would not be possible in Scala 2 because we couldn't represent this type for a start. But we would need to have a corresponding sealed trait. And if HTTP comes from one library and JSON comes from another library, that sealed trait simply can't exist. It can't have subtypes of net error and also subtypes of parse error and access error if they're defined in even different files, let alone different libraries. Scala 3 gives us that opportunity. And what we can do, therefore, is we can write a method like, we can handle a get count method, pass it a URL, and we can recover from that, and the compiler will tell us if we have handled every possible error from that or if we failed. The definition site, actually the type here will be inferred, so you don't need to write it, but generally in a library you would explicitly specify what the type is. I've got the type wrong. Maybe you noticed this should be project result. This is the domain, but it would project on the result. My feeling in general with this stuff in Scala 3 is that the algebra of the types is much more reliable. I can trust it much more to compose types together in different ways and produce what is a useful value for me at the end of it. With Scala 2, there was always a risk that it would widen the type too much, or it just wouldn't be able to represent the precision you wanted from in a least upper bound. This is, of course, a least upper bound of the results of these. So I'm generally very happy with the way this is looking. I think I'm quite hopeful for what we can get with Scala 3, and I wouldn't be surprised if Quarantine is useful to a few people on Scala 2, but really takes off when people start using Scala 3 and want to be doing exhaustivity checking, working only with total functions.